Hello students, let's today revise about chemiosmotic hypothesis, also called as proton pump. Dr. Peter Mitchell proposed the chemiosmotic hypothesis in 1961 and was awarded the Nobel Prize in Chemistry in 1978. The movement of ions across a selectively permeable membrane down their electrochemical gradient is called chemiosmosis, just as movement of water solvent across the membrane in osmosis. More specifically, it relates to generation of ATP by movement of hydrogen ions across a membrane during cellular respiration in mitochondria and during photosynthesis in chloroplast. In photosynthesis, these membranes are thylakoid and the protons accumulate in the lumen. In respiration, protons accumulate in the intermembrane space of the mitochondria. Due to splitting of water molecule on the inner side of the membrane, hydrogen ion accumulate within the lumen of thylakoid. So protons increase in number here. The NADP reductase enzyme is located in the stroma side of the membrane. For reduction of NADP to NADPH2, protons are required along with electron that comes from ferredoxin. So here the protons decrease in number. Hence, within the chloroplast, protons in the stroma decrease in number, while in the lumen there is increase in number. This creates a proton gradient across the thylakoid membrane. There is subsequent spontaneous movement of protons generating energy which is used for the synthesis of ATP. When hydrogen ion protons diffuse from an area of higher proton concentration to an area of lower proton concentration, an electrochemical concentration gradient of proton is developed. This electrochemical concentration gradient of proton across a membrane is harnessed to make ATP. ATP synthase is the enzyme that make ATP by chemiosmosis. It allows proton to pass through the membrane using the kinetic energy to phosphorylate ADP, making ATP.